Hello everyone, we're looking again at the Sound Machine's NS1 NanoSynth. Today I'll be walking you through this center section, the synthesizer block and the utility strip at the top. I've got the output from the filter right now is going directly to the main out. And I'm going to skip this black section because those are controls and go directly to the waveforms of the oscillator. We have triangle, which is very pure, almost like a sine wave. We've got square. We have sub, which is a square wave 1 octave lower. We have sol. We got white noise. And we got pink noise. Two slightly different flavors of noise. Now I'm going to use the square wave to demonstrate this next part. I'm going to mute that for a second while I'm talking. And we'll look up here at this block. We have C1 and C2 here at the end, which correspond to the controller knobs right here. And they have a 0 to 5 volt range, which is normal for this machine. It's a 0 to 5 volt unipolar system. Now, if I plug that into the volts per octave input, I'll set my oscillator's root tone lower, and I'm turning controller 1, which I have patched to the volts per octave. And over 5 volts, we theoretically have a 5 octave range. Now if I plug that into the CV input, the range is slightly narrower, and the CV input is not calibrated to volts per octave. The CV input is it's really for like a vibrato. So if I was to take a triangle output from one of my LFOs, and the volts per octave input, that's pretty wide. And in the CV input, it's a little bit narrower. And I can manipulate the speed of the LFO to change that effect. Now the next socket over here is sync. And what sync does is it restarts the cycle of the oscillator with the rising edge of the sync input. So let me turn the pitch up to about there. And really, to do sync properly, you have to have a second oscillator. I'm gonna use an LFO. I'll take the square wave output, and you can kind of hear that clicking. At this frequency, sync isn't going to do very much, but if I push the LFO up to its upper limits, that's what syncing the oscillator will do. This is without the sync signal, and that's with the sync signal. And this is much more dramatic if you use an actual audio frequency oscillator, which you can patch in from somewhere else using the Nano Bridge, or perhaps you can get it out of the Arduino. I don't know, because you need a computer for this, and I refuse to go that direction. Anyway, let's see what's next. Oh, PWM was pulse width modulation. And if I plug into that, it will affect the pulse width of our square wave. Now there is a pulse width knob down here. And if I turn that, you can hear it changes the timbre of the square wave. Now pulse width only affects the square wave. It won't do anything to any of the other waveforms. And the pulse width modulation allows you to modulate that using CV. So if I again use my triangle wave and plug that in, now you can hear it modulating the pulse width. And you can use one of the attenuators to control the depth of that effect. The attenuators are these two blocks over here next to the oscillator. They have a 5 volt and a 0 volt on it, and then 2 inputs, 2 outputs. So if I plug my LFO into one of the inputs and then take the output and plug that into, let's say, the pitch CV, then I can use the attenuator to trim that voltage and control the depth of the effect. Handy. Now, what is next? Well, I kind of skipped over this mysterious thing. This is the sum sub. And it's marked with 2 inputs. One of them has a tiny little plus, one has a tiny little minus, and then there's an output. Now the formula for this is the output is the plus minus the minus. So if I wanted to, I think the best way to demonstrate this is to use it as kind of like a cheap VCA. So I'm going to take, let's see, I'm going to jump the input of the filter and take that from this mix over here. You have 3 mixers up here in the top row. There's one labeled mix, there's another one down here labeled mix, and then there's one called mix-3/3. Mix over 3 is a 1/3 mixer. It divides all the incoming voltages by 1/3, and then the output is supposed to be everything is optimal, and you use that so it won't overdrive the filter. The regular mix is a unity mix, and it supposedly mixes everything together at the same level that it comes in. And I'm going to use the unity mix for this. Now, I have the output of the mix plugged into my filter, and there's my square wave coming in. And if I want to mix in some sub, but I don't want it to be there all the time. But I only have one VCA. Since I'm not using the VCA right now, I could theoretically just use the VCA to do this, but I'm going to use the sum sub utility. If I take my sub-octave output and plug it into the plus, and then I take one of these LFOs, triangle wave, and plug that into the minus, and then I take the output of the sum sub and add that to my mix. Let me unmute this. So there's the square wave by itself. And there is the output from the sum sub. And I can slow that down by adjusting the LFO. However, it's operating backwards. I don't know if you can see this light, but because it's subtracting voltage, it goes off when the LFO is high. So in order to invert that, I would need to take that LFO and run it through the other sum sub with a 5 volts on the plus side. Let me see if I can do this. It gets real crowded. If I take 5 volts from this voltage section, they're labeled 5, 3.72, and 1.25. So I'm going to take the 5 volts and plug that into plus, and plug my, can't reach these tiny things. Okay, then plug my LFO into the minus, and then take the output of that, because now it's 5 volts minus the LFO, and we plug that into the other sum sub, and now if we listen, our sub octave is fading in when the LFO is high. And this video is about at my limit time-wise, so I'm going to have to cut here and talk about the rest of this in the next one.